Okay, today I'm going to be explaining composite functions and operations. So this is basically everything that's covered in topic one test of Math 621B. I'm going to be going over main questions that people were concerned about, but it's basically going to cover each of the composite functions and some different operations and some different questions that could be on the test. So we're gonna start. I have it numbered of what they are in the practice booklet, so if you want to go back and look at that and follow along, you can. So this one's number 13. So this is the one where f of x equals 3 times the cubed root of x negative 4, and g of x is x plus 2, and then it also stated that x has no restrictions, so it's part of the real number system. So here we're asked to write an f of g of x and f of g of x applied to 2. So basically, the fog, otherwise known as fog question, is basically saying f of g of x is equal to f of applied to g of x. So basically it's saying that function f, this is just like the what function is. So function f has its equation filled out by g of x. So g of x is just the placeholder for this equation here. So it's basically saying that function f, which is this equation, applied to our g of x equation. So it's honestly more simple than it seems. So we're going to do that. So our f of x equation, which is our 3 times the cube root of x negative 4, our x is actually going to get replaced with the g of x equation. So it's going to be x plus 2 negative 4. Okay. And then we can further write this as x plus 2, take away 4, x plus 2. All right, so that is our fog. That's our equation there. Okay, now we are going to do this equation, which we just found, and we're going to apply it to 2. So let's write out that equation just to start with so we can see what we're working with. Equals 3. Okay, and now if we're going to apply it to 2, we're going to have to switch out our x with 2. So 3 cube root 2, take away 2. And this is ultimately going to be a 0. So it's going to be cube root 0. So it's actually going to end up 3 times 0 is 0. So our fog of 2 is equal to 0. Now, if we're going to find the inverse of x, of the f of x equation, we're going to write out our f of x equals 3 cube root x negative 4. So this is our original equation. And if we're going to want to do the inverse, we're just going to switch out the variables. So instead of this having a y here, it's going to be x equals 3 cube root y negative 4. Now we're just going to write this all out so that we can have y equals something so we can get our new equation. So it's going to end up being x over 3 equals cube root y negative 4, cube both sides, x over 3 cubed equals y negative 4, and then y just equals our x over 3 cubed plus 4. So that's going to be our inverse equation. So we can actually just cross that out and put, and that's our inverse equation there. You can also, the answer would also be equally as right as if you applied the cube to that and just took it out. But it's honestly just easier to leave it like this. But for the answer for that would be, uh, whoops. Yeah, so that's the answer for that. But I would just recommend sticking with this. This is just useless, really, unless you're doing a vertex form. So yeah, next question. Okay. This is number 14. F of x equals x squared, negative 5x plus 9, and g of x equals x plus 2. All right. Determine f of g of x in standard form. So our standard form is the form where we have y equals ax squared plus bx plus c. So that's just our standard form there. So now our f of g of x. So we stated earlier that f of g of x is equivalent to f of g of x written like that, and it's easier to understand that basically it's this function being applied to that. It's basically, you think of it kind of like a transformation, like this function, which was this, is being transformed so that it fits into here. That's another way to think about it. It's really just that it's being applied. Okay, so this should equal, we're basically just going to take down original, and we're just going to substitute all the x's for this. So instead of x squared, we're going to have x plus 2 squared, negative 5 times x plus 2 plus 9. So you can expand this out if you're writing it. I'm just going to do it the faster way. I'm going to explain the faster way. Basically, when you have something being squared, you can square the first term, and then you times it by the second and times it by 2, and then you just square the last term. So if I did it here, the first term squared would be x squared, and then times it by the second term is 2x, times by 2 is 4x, so you add 4x, and then the last term squared is just 4. So it's that. And now we're going to do this part. So negative 5 times x, negative 5x, and negative 5 times 2 is negative 10, and then we just add our 9 on the end. So now we can just compress everything down. We only have one x squared, so that's going to stay the same. We have a 4x and a negative 5x, and that's all of our x's. So we're going to have negative x. Cross those out. And now for just constants, we have our plus 4, negative 10, and plus 9. So negative 10 plus 9 is negative 1, plus our 4 is going to be our plus 3. So that is what it's going to be in standard form. Okay, so now we have B, which is evaluate f of g of negative 4. So basically it's saying that this graph that we found is going to be applied to negative 4 so that negative 4 is transformed by it. So if we go back up and look at what that graph is, it's x squared negative x plus 3. So f of g of negative 4 is going to equal this graph with negative 4 substituted into it. So we're going to have negative 4 squared, negative, negative 4, and then plus 3. So we should have negative 4 squared is 16, negative, negative 4 is just going to end up being plus 4, plus 3. So it should end up being 23. And that will be your answer for that. 15. Graph the inverse of the parent function, y equals f of x, and then b is f of x invertible, explain. So the easiest way to graph this parent function as an inverse would just be to get the points and then switch the x and y values. So let's do that. So a is negative 1, 2, 3, 4, 5, 6, 7. So negative 7, and then up 1, 2, 3, 4, 5, 6. So it's going to be negative 7, 6. Okay, so when we get to B, it's going to be negative 1, 2. So negative 2, 1, 2, 3. Negative 2, comma 3. All right, and now for C, let's go ahead and count. So it's over 1, down 1, 2, 3, 4, 5, 6, 7, 8. So it's going to end up being 1, comma negative 8. And then D is going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. All right, so that's all of our originals. So now when it's an inverse, the points are just going to be flipped. So we can do that over here. So instead of negative 7, 6, it's going to be 6, 7. It's going to be 6, negative 7. And then for B, it's going to be 3, negative 2. And then for C, it's going to be negative 8, 1. And then for D, it's going to be 7, 5. So let's go ahead and graph that. So A is positive 6, 1, 2, 3, 4, 5, 6. Negative 7, 1, 2, 3, 4, 5, 6, 7. So that's point A. B is going to be 3, negative 2, 1, 2, 3, 1, 2. C is going to be negative 8, 1, 1, 2, 3, 4, 5, 6, 7, 8, 1. D is going to be 7, 5, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. So that's D there. And that's your inverse. So that's going to be the answer for A. B is f of x invertible, explain. So first of all, let's go ahead, get this out. So it passes the vertical line test, but it does not pass the horizontal line test, as you can see. So it is not a one-to-one. And that means that if it's not a one-to-one, that it's never going to be able to be invertible because either it's not a function to begin with, or it's going to become a relation when it's inverted. In this case, it does pass the vertical line test in the parent function here. So it is a function, but the thing is that when it's inversed, we now have the vertical alignment. So it's no longer a function at all. It's just a relation. So, and if for you to explain it, you would just say no, does not pass. Um, Vertical line test, therefore inverse relation. There. All right. 18, graph the function and its inverse and determine the explicit equation and be sure to include the correct domain. So to graph the function, we know that it's a square root function, so we know that it would usually look like this, something like that. However, it is being reflected in the x-axis, vertically stretched by 5, moved 1 unit right and 4 units down. So if we want to reflect the 0 in the x-axis, obviously nothing's going to happen, can't vertically stretch it, so we're just going to have to go right 1, down 1, 2, 3, 4. So this is where your first point's going to be. And we know because it is reflected in the x-axis and it's like a negative number, it's going to end up looking like something like that. So the next point is 1, 1. So reflected in the x-axis, it's going to become negative 1 times by 5. It's going to be negative 5. And moved right 1, down 4. So it should end up be right here. A third point we can't do because it's going to be off the graph, but I'll tell you the importance of that in a second. So it's going to look something like that. Okay, let's say this is point A. This is just to get our inverse. This is point B. So A is 1, negative 4, and B is 2, negative 9. Okay, so now we know that on our inverse, A is going to be negative 4, 1, and B is going to be negative 9, 2. Let's go ahead and graph that, starting with our negative 4, 1, 2, 3, 4, 1, and 5, 6, 7, 8, 9, 1, 2. So that's where our 2 points are going to be. However, it might look like the graph is going to go like this, but we have to remember that if this third point was on, it would be like somewhere up here, so the graph is going like this. You just have to make sure to look out for that if you're only doing 2 points. So you have to make sure that you're going to graph it properly. So it is going to look like that. Um, and then so just make sure to include the correct domain. So I'm just going to show you the domain for the first one. So for the normal function, we know that x is greater than or equal to 1, and y is less than or equal to -4. And we can just get that from the points here, or we can also get it from the graph. Um, and we know that in the inverse, it's flipped. So we know that y is greater than or equal to 1, and x is less than or equal to -4. So that's what the domain and range is going to be for that. And I'll show you how to apply that to our explicit equation right here. So we can just go ahead and do this. I don't really have to write everything out. Y equals -5 square root y, -1, -4. So basically I just swapped what the variables would be. So now we just have to solve and get y by itself. So x plus 4 equals -5 square root y -1. And then we're going to divide both sides by -5. So x plus 4 over, just bring the negative out there because I don't like it on the bottom. Equals square root y -1, square root both sides, like so. And we get x plus 4 squared equals y -1. And then y equals our negative x plus 4 over 5 squared plus 1. That is your answer there. There we go. I am just going to put it into vertex form so that you can see where we get our domain and range, like how this applies to it. So we're just going to take out the 5. We're going to take out the negative, like 1 over 5, and we're just going to put it as 1 over 25 because you just square it. So it's going to y equals 1 over 25. Basically, that's just how this negative was part of this, and x plus 4 divided by the 5 is the same as x plus 4 times the -1 over 5, so we can just take that out, times our x plus 4 squared plus 1. Now we can see here that our domain, we have to bring our domain from down here, less than or equal to -4. And then we can see that the y has to be greater than or equal to 1 here. And there you go. So that should be your answer here. Oh, you should probably in the test put that. I believe that's what he wants. So that's what your answers are. Okay, number 19. So show that f of x equals 5 over 2 negative x plus 2 is self-inverting. So when a question asks, is it self-inverting? It's basically saying when we uh, bring this into a inverse function, or when we change it into an inverse function, is it just going to be the same as the normal function? And an easy way to do this, well, I mean, you can just find the inverse function and then just see if they're the same. But a cool way to think of it is that the point of an inverse function is to undo the original function. So that means if we're to apply the inverse function, like so, if we're going to apply the function of the inverse function, it should just get rid of it. Its point is to undo it. So it should just leave us with x, because it should just be f of x. So in that sense, we can say that if the inverse function is equal to our normal function, the function that we put inside the brackets shouldn't have to be the inverse. If we put the normal function, it should just get rid of everything, bring it back to x. So that's an easy way to look out for it. So we would do f of x. And basically, this is saying that it should be the same because if they're equal to each other, it should do the same thing. So Let's see if we get x here. So this equals 5 over 2, take away 5 over 2, take away x, plus 2, plus 2. Okay, so let's just simplify the bottom because that does not look nice at all. So 2, negative 5 over 2, negative x, negative 2. So these can cancel out. 5 over negative 5 plus 2. So what we can do here, instead of dividing 5 by the 5 over 2 negative x, it would be the same as like doing timing it by the inverse. So we can do 5 times, sorry, 5 times negative 2x over 5 plus 2. So this is going to be the same thing as how it's written up there. And because this is the same as 5 over 1, we know that these can cancel. So it should be negative 2 negative x plus 2. And we can just apply the negative 2 plus x plus 2. These are going to cancel out, and you're left with x. So that does show that it's self-inverting because it shows that this f of x does the same as what an inverse would. So that is how you show it's self-inverting. The other way, and I guess could be the easier way if you can't do like fractions on the bottom, would just be to find the inverse of this and to see if it equals the normal. But this is how I like to do it because it kind of shows how everything works. Okay, so f of x equals 2x negative 1, g of x equals 6x negative 5. Write the equation for f times g of x, okay? This is not of, this is times. That, ugh, they look so similar and it's really annoying, but the filled in dot means multiplication and the empty dot means that it's going to be like of. So, and then determine domain and range. So just make sure you're looking out that this is filled in or not. So let's go ahead and write that out. So f times g of x, this is going to be equal to f of x times g of x. And that will be 2x negative 1 times 6x negative 5. Let's multiply this out. 2 times 6, that is going to give us 12x squared. 2 times negative 5, negative 10x. And then negative 1 times 6x, negative 6x. And then negative 1 times negative 5 is just plus 5. It's going to give us 12x squared. You're going to want to add those together. So negative 10x and negative 6x is going to give us negative 16x and then plus 5. So this is in standard form. We want to determine the domain and range. So the easiest way to do that is to get this into vertex form. So how we're going to do that, usually I would do this by completing the square, but I think for this equation, it's going to be easier to show if I just do the negative b over 2a formula. So this is a, this is b, this is c. And our h equals negative b over 2a. It's going to equal 16 over 2 times 12, which is going to equal 16 over 24, which is equivalent to 2 over 3. So that is our h. We can now plug h into this equation to find our y value, which would be our k. So I'm going to go ahead and do that. I'm going to write it as k, but you can think of it as y. 3 squared negative 16 times 2 over 3 plus 5. So 2 over 3 squared, so it's going to be 4 over 9 times 12. Take away 16 times 2 over 3, so it's going to be 32 over 3 plus 5, and then 12, 12 divided by 3, You can do this with the calculator. I'm just going to do it in my head. So I can do 12 divided by 3 is 4. 4 times 4 is 16, so we get 16 over 3. Take away 32 over 3 plus 15 over 3. 16 take away to 32, negative 16 plus 5. So we're going to get negative 1 over 3. So that's going to be our k. We can now put this in vertex form. So we have to take our a. So let's just bring this back down. X equals a 12 times x negative 2 over 3 squared negative 1 over 3. So this is vertex form. We can now determine domain and range. We know because there was no restrictions on the original equations that there's not going to be a restriction on the x because it is a parabola, which means x can go on forever. So for domain, we're just going to have x, product of all reals. And for range, because it is a parabola, we know that there is going to be a restriction on y. So it's product of all reals, and it has to be greater than or equal to negative 3. Oh, sorry, negative 1 over 3. And that is going to be your restrictions. Okay, that is that question. We are going to go on to 22. Okay, so determine the solutions to f of x equals the inverse, and f of x equals x negative 1 over x plus 8. So basically this equation in my last video, it was the same idea. It's basically just asking at what point do the graphs equal each other? So at what point do they intersect, basically? Like what points do they share? So what we're going to do here is basically we're going to find out what x has to equal for them to be the same thing. Let's go ahead and get our inverse. X equals y negative 1 over y plus 8. And we're going to have to multiply both sides by y plus 8. So this cancels. Okay, and then x plus 1 equals y negative 1. Let's go ahead and multiply this out. Xy plus 8x equals y negative 1. We're going to subtract 8x from this side and add it over here. Oops, sorry, not add. We're going to subtract it over here. And we're going to take away y from this side, take it away from this side. So xy negative y equals negative 1, negative 8x. And we're going to have to get this x onto this side. And to do that, we're just going to have to take out the y from it. And because we can see that y is times by x and y is times by negative 1, we know that y is the common factor. So we can actually take that out and we can just do x negative 1. Because if you see, x times y is xy, and then x times negative 1 is negative x. So it's going to give you the same result. Equals negative 1, negative 8x. Now we're going to divide by both sides by the x negative 1. So y equals negative 1, negative 8x over x negative 1. So that is going to be your inverse equation. If you don't want it to be in fraction form, you can actually go ahead and divide that even more. Sorry, you can actually write it as this. And 1 over x negative 1, negative 8. So you can write it like that if you want vertex form. I don't know for sure how he wants it written out. I'm going to use this equation. It is way easier to use this equation for this problem, but I will put it in the description if he wants it like this or not. I don't think he will because it's honestly just completely unnecessary, but I will put that in the description. So let's go ahead and put our equation for f of x equals the inverse and find the points, what x has to be for the points to be the same. So x negative 1 over x plus 8 equals our negative 1, negative 8x over x negative 1. Now, to get everything, we don't want any fractions here right now, so we're just going to times both sides by the denominator. So this side's going to be times by this, and this side will be times by it, and then this side will be times by here, and this side will also be times by it. So x negative 1. We're actually going to bring our thing over here, equals negative 1, negative 8x times x plus 8. Now let's multiply everything out. X times x is x squared, negative x plus 1 equals, let's get those, negative x, negative 8, negative 8x squared, negative 64x. Okay, and then that's just going to be x squared, negative 2x plus 1, and this side's just going to be negative 8x squared, negative 65x, negative 8. Now I'm just going to bring everything over onto this side because I feel like it's going to be easier. You can bring it onto whatever side you want. It's just that we're trying to solve for x so that we can see what the point has to be. So x squared plus 8x is going to be 9x squared, or sorry, plus 8x squared. Cancel those out. Negative 2x plus 65x is going to be positive 63x. And then positive 1, positive 8 is going to be positive 9. It's going to equal 0. Everything here is divisible by 9 as well, so may as well just do that. Simplify it, make our lives way easier. X squared plus 7x plus 1 equals 0. Now we're going to have to do quadratic equation because we cannot factor that out so that it can add up to 7, which kind of sucks. I hate quadratic equation. It just takes a long time for literally no reason. So x equals, the equation for this is negative b plus or minus the square root of b squared negative 4ac over 2a. So I'm going to do that. Negative 7 plus or minus square root 7 squared, negative 4 times 1 over 2 times 1. So this is going to be negative 7 plus or minus 49, take away 4, which is 45 over 2. 45 is divisible by 9 and 5, and 9 is a square root, so we can actually take that outside. Plus or minus 3 square root of 5 over 2. And that's as far as we can go with simplifying this because we cannot divide 7 nor 3 by 2. So x is going to equal negative 7 plus 3 square root 5 over 2, and x is going to equal negative 7, negative 3 square root 5 over 2. Okay, so now you have to use your calculators for this. Rounding, this is going to equal about negative 0.15. That should be the answer that you get there. And then this other one is going to be about negative, it should be negative 6 point something. Let me just see. Yeah, so negative 6.85. That should be your answer for there. So that's going to be the 2 points where they intersect. So 23. That is our last question. Before I get done of this last question, these are all just like the rudimentary or like principal concepts. I do have a bunch of other practice questions if you guys want me to do a video on that where I'm not rushing through a concept. You can message me or you can put it in the comments and I'll make a video on that where I explain it more in detail. Um, but yeah, other than that, this is the last question, and I think this should cover everything. So f of x equals 2x negative 5 and g of x equals 6x negative 5. Determine g over f of x in its domain and range. So g over f of x is the same of g of x over f of x. So let's go ahead and write that out. G of x over f of x. And this is going to be equal to 6x negative 5 over our 2x negative 5. That is what our g over f of x is going to be equal to. And we have to find domain and range. So we know because, let me just write this out. This might be kind of hard concept or just might be confusing for me to say. But basically because we know that it's a reciprocal function because it's something over something, we know that there's going to be horizontal asymptote and vertical asymptote. So we know right away that there's going to be there's going to be one restriction on each variable. And this is going to be obvious for most that this right here is going to be equal to our horizontal or to our vertical asymptote because we know that it can't be equal to 0. So we can do 2x negative 5 equals 0, 2x equals 5, x equals 5 over 2. So we know that this is what x has to be for the denominator to be 0, and we know that it will be undefined if we do that. So we know that x cannot equal 5 over 2. So we would do x cannot equal 5 over 2. Something that you probably don't know is that these two numbers here actually give you your vertical asymptote. So 6 over 2 would be your vertical asymptote. So y cannot equal 3. That's the answer there. I will put this into vertex form just so we can see that better. So what you're going to want to do here is you're going to have to, if you don't want to do the shortcut like that, you're going to have to do your long division. So 2x negative 5. And then you have your 6x negative 5. And this is going to be 3. 3 times 2x, 6x negative 15. We want to put that in brackets, put negative so that these cancel out. And this is going to become a plus. So negative 5 plus 15 is going to be 10. 10 is going to be our remainder. So we'll just do plus 10 over 2x negative 5. And that will be, we can rewrite it like this actually. 2x negative 5 plus 3. If you want, you can take the 10 out and just write it as 10, 1, 2, x negative 5. Doesn't really matter. It's up to personal preference, but you don't need that to find the answer. So basically this, oops, you know that when you're doing your, when you're doing a reciprocal function graph, that there's going to be the vertical and the horizontal. And we know that this point of the vertical and the horizontal is always like what the vertex would be. So to find the vertex here, we see that there's a horizontal stretch, so we can't say that negative 5 is, or that 5 would be the vertex. So we would have to do 1 over x negative 5 over 2. So that's what gives us our positive 5 over 2 right here. And then this is what gives us our positive 3 here. So that just kind of shows how to get that. Yeah. So that's the last question. I have a bunch of practice questions that I made. If you want me to do a video going over those, just let me know. I'll probably I don't know how to make a link to them. I might make a Google Doc and put the link in the description so you guys can do that if you want extra problems. Um, and if there's anything confusing in this, just let me know. And I kind of rushed through it. So if you let me know, I can either just talk to you one on one and kind of explain it, or I can just make another video specifically for something that you don't understand. So yeah, that's going to be the end of this. And hopefully that helped a little bit with what we're doing. I was rushing through it, but yeah, hopefully that helped.